Then the last problem is a system of three equations. And so there are lots and lots of ways you can solve this depending on if you choose to eliminate variables and which variables you want to eliminate first. Or you could do substitution and which equation you want to solve for and plug into what. So there's lots of ways to approach this. And I'll be honest, I tried it 2 or 3 times and I made little mistakes each time, subtracting negatives and whatnot. It's difficult. You've got to take it slow and not rush through this problem and be careful about it. So here's how I did it. But like I said, there's many ways to set this problem up. I took the first two equations and decided to eliminate x by multiplying the first equation by 3. So I got the 3x and the 3x. And so then I could take that new first equation, 3 times r1, and subtract r2. And so I get 3y minus negative 2y is 5y, and that's one place I made a mistake the first time. And then I get 3z minus z is 2z, and I get 2 times 0 minus 3, which is minus 3. Also, I made a mistake the first time I did that with just putting 3 there. So be careful when you're subtracting these things. And then I kept the third row by itself, or the same, and I have this new system of equations. Now there's no x's involved. I got kind of lucky because there wasn't an x in the third equation, so I didn't have to eliminate there, so that saved a step. And so now I have the blue box, which is two equations, both in terms of y and z. So I can use those to solve. And in this case, I noticed that the 2z and the minus 2z were set up so I could eliminate them easily. So I chose to eliminate the z's by adding the two equations. And when I add the two equations, I get 5y plus y is 6y. 2z minus 2z disappears, and minus 3 plus 9 is 6. So, yay, 6y equals 6, so y is 1. And once I have that, I can plug that into the other equation, and then back substitute and solve for z. Z ends up being negative 4. And then once I have those two, I can plug the y in here and the z in here and solve. My original equation was x plus y plus z equals 0, so I can solve for x, and it turns out it's 3. And since I had messed this up twice along the way, I figured it was worth trying, just make sure this double checks, plug it into the other equations. To be honest, that's how I found out that I messed up. I plug that back in to the x plus y plus z equals 0, and it works. I plug it into the second equation, 3x minus 2y plus z, and it does, in fact, equal 3. So I was happy. And then y minus 2z equals 9. Well, that works because that's how I found z to begin with. But so these problems are, I'd like to say straightforward, but tedious. So there's a process you can always do, either substitute or eliminate, to just keep getting rid of variables. But they're tedious. You've got to watch all your subtractions and make sure you do it all correctly. And as organized as you can get, that's the better. So I hope that worked out. I hope you found your method to solve that problem and it worked out to get the same numbers.